Hey, what's up, Bulldogs? This is from the point slope notes from today. I want to finish this up just a little bit. And what we need here to create a point slope form equation is a point and a slope, right? That's it. That's all you need is one point, any point. You could use this point, this point, this point, this point, or this point, but we do need a slope. So there's two ways to do this. I can say this slope is, we know that slope, M, is the change in Y over change in X. So what is the change in Y? Well, let's pick 2 points. Any 2 points, it does not matter. I'm going to pick this point right here, this point right here. This first point is 2, 1. Second point is 1, 3. So we know that this is x1, y1. We'll call this x2, y2. So what's the change in y? Well, it's another way to say this is y2 minus y1 over x2 minus x1. There's so many ways to say this. Rise over run is another way to say this. Rise over run equals m, which is slope. Change in y over change in x equals y2 minus y1 over x2 minus x1. This is all the slope. Basically, do you want to ski down this slope? Well, first I want to know what the slope is. How scary is it? So, y2 is, as I'm looking over here, 1. Minus y1, 3. All right, that's a negative, right? 1 minus 3 is negative 2. Well, first let's find out what the change in x is. So again, we're going here. x2, that's a 2. Minus x1. That's a 1. So what's 1 minus 3? That's a negative 2. What's 2 minus 1? That's a 1. We know that the slope is negative 2 over 1. Negative 2, it doesn't matter. And we also can look at the slope and see that this line is actually going from left to right. It's going down, so we know it's a negative slope. So if I know my slope equals negative 2, right? Because negative 2 over 1 equals negative 2. All I got to do now is pick a point. Any one of these points. I'll even pick this point up here, which is negative 1, 7, right? That point right there. It doesn't matter which point. I can use any one of these points. This linear equation is still going to be the same thing. So what is the linear equation that we use here for point slope form? Y minus y1 equals slope times x minus x1. And notice the y1 and the x1, that means you're actually going to put a real number in there. And then the regular x, this one here, and the regular y, you're going to leave alone. And those will be your variables. They will vary. They will change as you change the inputs. So I'm almost there. What am I going to write? Y minus, well, I said I'm using this point here. That's a 7. Y minus 7. It's a positive 7, so it's y minus 7. Equals, what's my slope? Oh, it's negative 2. Times what? X minus, that's a negative 1. So if I'm going to simplify it, all this is going to be y minus 7 equals negative 2 times x plus 1. And that is your answer. All right. Convert the following equations from point slope into slope intercept. We can do that. We know what slope intercept is. It's y equals mx plus b. All we want to do is get this here to isolate the y, right? So let's do it. First, we're going to distribute this 2, right? So you get y plus 4. Actually, that's here. Equals 2x minus 2. I then subtract 4, I subtract 4, and folks, my answer is y equals 2x minus 6. And that's it. Same thing over here. Distribute the 3, the negative 3. Y minus 2 equals negative 3x plus 18. Add 2. And folks, y equals negative 3x plus 20. What's the slope here? It's negative 3. Slope is negative 3. If you care, up here, the slope is 2. Because look, 2. And over here, I said negative 3. It's 3. What's the y-intercept? It's a negative 6 up here, right there. Over here, it's 20. Okay? I'm just a little. Finally, distribute the 2/3. We've got y plus 2 equals 2/3 x minus, basically, 2/3 times 3/1. Continuing, y plus 2 equals 2/3 x minus 6/3. Continuing, y plus 2 plus 2/3 x minus 2. Oh, shoot, sorry. This is equal and equal. I'm not done isolating the x, am I? So minus 2, and you get y equals 2/3 x minus 4. Slope equals 2/3 if you care. And y-intercept equals anybody? Negative 4. Got it? All right. And then let's do 12 here. What do they want us to do? They want us to write an equation in point slope form. Okay. I need the slope. What's the slope? It's y2 minus y1 over x2 minus x1. M equals that. That's the slope, right? It's the change in y over change in x. It's rise over run. So it doesn't matter what I write down here. I'll write x1, y1, x2, y2. Cool? Great. I'm glad you agree. So what is y2? It's 1. 1. So you get 1 minus a negative 8 over negative 7 minus 5 equals 1 plus 8 over negative 7 minus 5 equals 9 over negative 12, which equals a negative 3/4. That's what it simplifies to. And if I'm thinking about a graph, 5, negative 8, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. That'd be 5, negative 8. And then negative 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. And I could see that this graph goes down and to the right, so it should be a negative slope, and it is. But I'm not done. I have to put in point slope form. I can use either this right here as a coordinate. So I would rewrite this as, let's pick a nice color. How about purple? What is the formula for point slope form? It is y minus y1 equals slope times x minus x1. And now I'm going to use this point. Y minus negative 8 equals negative 3/4 times x minus 5. That's it. I could rewrite it as y plus 8 equals negative 3/4 times x minus 5. I could have also picked the other point, negative 7, 1. So y minus y1 equals slope times x minus x1. Plug it in. Y minus 1 equals slope, which is, slope, which is negative 3/4. Oh, no. Oh, yeah. Times x minus a negative 7. Y minus 1 equals negative 3/4 times x plus 7. That's what it turns out to be, right? Because when you subtract a negative number, you're actually adding it. And folks, this and this are going to give you the same exact line. It's going to give you the same exact line. I promise. That's it. And you can see right here. Whoop, those are the 2 points. That's, I believe, negative 7, 1. All right. If you're really curious about this one, I will do it. If you feel like you've got it, you may go. But otherwise, copy right here, paste. Oh no, I need a slope. What is slope? Oh right, I know what it is. It's change of y over change in x. Change in y. It's a change of y. Change in y. Change of y over change of x. Change of x. Let's go with of. I'm gonna ask my math department tomorrow. Or rise over run. There are so many ways to say it. Anyway. Oh, or y2 minus y1 over x2 minus x1. So, let's just say x2, let's just say equals, and I'm going to label them. So we'll call this x1, y1, x2, y2. So it's y2. And it doesn't matter, actually. I could also do it this way. It actually does not matter. x1, y1, x2, y2. This is the amazing thing about math. This still works. So what is y2? We'll say negative 3. Negative 3 minus 6 over negative 4 minus 2 equals. This is a negative 9. When you have a negative and you are adding to it another negative, or you're subtracting a number, you're going to add those two numbers and take the big sign. So you really have just negative 9 over negative 6, which equals 9/6, which equals 3/2. So that's a positive. What if I'm not sure? Well, why don't I just graph it? Negative 4, negative 3. 1, 2, 3, 4. 1, 2, 3. There we go. Just want to see if it's positive or negative. 2, 6. 1, 2. 1, 2, 3, 4, 5, 6. And folks, what you have is a line. It's going up and to the right. Positive number, positive number. But we're not done. We still need to write this all in point slope form. So, it doesn't matter which one I take. I'm going to take the 2, 6. Okay? So y minus, not a great y. Y minus 6 equals 3/2 over x minus 2. Done. There's your point slope form, kids. You could also do it with the other point, negative 4, negative 3, and you'll still get the same line. Hope this helps.